Hello and welcome to my YouTube channel. My name is Siobhan Richards. So the last time we covered data types in Java. Today we want to look at typecasting. So what is typecasting? Well, you're moving from one data type to another data type, right? And this is typically done on the primitive types, right, in Java. Okay, so for example, you have this function. It takes in some data type. And you want to typecast it to another data type to return it, right? So typecasting is important, right? So it's a means of switching from one data type to another, okay? All right, so there are two types of typecasting. You have implicit typecasting as well as explicit typecasting. For implicit typecasting in Java, the compiler automatically assign the type, right? So based on whatever assignment you're trying to make, it'll take the right type for the assignment. So what I mean is, let's say you have a double in your assignment operator and you're doing an addition, right? So you can only assign that value to a double type, okay? And we'll look at that some more. Explicit typecasting is you telling the compiler this is the type that I need, right? So just to note, the main difference here is implicit is automatic while it's built into the language. Implicit is built into the language, while explicit is you telling the language this is what I want to move from. Okay, so it's not automatic. You're telling the compiler this is the type I want from the type I had before. Okay, so for implicit typecasting, the way how it automatically does this is via precision. So the data type with the most precision has higher order of preference. Okay, so double has the highest precision, followed by float, long, int, short, byte. Right, and there's no bool here because bool is a non-numeric, right? I mean, character is a non-numeric as well, but it's the ASCII value. It can be converted to the ASCII values. Okay, so let's look at typecasting in Java. Let's first look at implicit typecasting here. Okay. All right, so we have our Java compiler here. It runs. So let's start creating some data types, right? So let's do int my int operand. Okay, and we'll see why we call these operand later when we look at operators. Remember, the int is very large. I think it's 32 bits, right? So let's do 20,000. Okay. Next one, we could do double, the highest precision. My double operand. Let's do, what's that? 10,000, 100, 1 million. Okay. Let's do float. Oh, let's add some decimal places here. Let's do float. My float operand. Okay. Okay, and then with Java, you need that F. Okay, at the end. And then we could do long. My long operand. Let's do 30,000. Okay. Short. My short. Okay. And let's make this 32,000. Very close to the limit, right? Let's do byte. Byte is 8 bits, right? So my byte operand. And then for byte operand, let's make this 102. Okay, we can't surpass 127. And then character type, my char operand. Let's change this to my here. We can set this to a character value. Let's set this to dot or something. Okay. So whatever printable character you have there. Okay, so that should be 1, 2, 3, 4, 5, 6, 7. We missed one. So we have the two double, short, long, int, byte, float. Okay, and then the last one would be Boolean. Okay, but let's look at the Boolean. We can't really add Booleans, but we'll look at that. So my bool operand, set it to true. Okay. All right. So that's all our variables there. Okay. So let's now do a very simple operation, adding all these variables and evaluate implicit typecasting in Java. Okay. So let's say we are trying to add all these variables to an int. So int add result. Okay, so that's the add result. Okay, so do my int operand, plus here. Let's do tab over my float operand here, plus here my long operand, okay, my long operand here, the other one my double, okay, we also have my short, okay, we have my byte, we also have my char, we have my bool. Okay. Okay. So we could do a semicolon there. All right. So we should have 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. Right. Remember those 8 primitive data types. Okay. So if we run this, so we declare, it says bad operand types here. Okay. Bad operand types. Okay. And also this one, they're saying it's a string. Let's do dot here. Let's do a semicolon for now. Okay. All right. So bad. What you want to see here is this bad operand types here, right? So it's basically saying you can't add Boolean operand. Okay. So let's comment that out. Put semicolon here and see if this error statement goes away. Okay. Okay. So now it's saying, oh, I think the issue here was single quotes here. Okay. Okay. So my byte operand. So here, this is the error we're looking for. Incompatible types. Okay. So it's saying the byte operand, right, is incompatible loosely conversion from double to int. Okay, that's because this double here has higher precision, right? Higher precision than the other types inside this assignment. So over on the left hand side, you can't assign it to an int. So let's make this a double, since we have a double here. Okay, there you go. Right, so you see, you have to make sure that the highest type on the right hand side matches your left hand variable, your left hand assignment. So this type that's implicitly done by the compiler doesn't want you to give a lower value to a higher a lower precision to a higher precision over here. And the reason why you could lose precision, right? You will lose decimal places and stuff, right? Accuracy and so on. But if we wanted to make it so that we want a lower precision, we could do explicit typecasting, okay? But for now, let's do this. Let's print. Let's keep on this. print line, and then add result. Okay, so let's do that. Got some results here. That's good. So what if we remove the double here? Okay, if we remove this double, it'll still work, right? But the problem here is you're assigning a double, right, to these lower level precision. So you don't need this much space for these lower level values here. So the one that is highest is the float. So you might want to change that to a float. So if I run this, I'll still get a double value, but the highest precision in the addition operation here is the float. So let's make this into a float. Otherwise, we're overcompensating for the values inside our operation here. Okay. Right, there you go. Okay. Okay, so that's implicit typecasting. And again, like, what if I try to make this an int? It wouldn't work, right? It's gonna give that loosely conversion error again. Okay, incompatible types, loosely conversion from float, which is the highest on the right hand side, to int, right, which is your left hand side. So make that a float. Okay. And you could do this on and on for your data types. Okay. The one thing you should observe is this character type here. It converted into that ASCII encoding. Okay. So this character type actually converts to a value when it's when an operation is done on it. Okay. So how do we know the value of this character type? We could do some explicit typecasting. So we could just do a brief explicit typecasting here. So we could do system .out.println, and then we could typecast the int to an integer value. So we need an int. Okay. And then we need the expression or the variable name. So my char operand. Okay, and then we need a space here. So this is explicit typecasting, by the way. Okay. So if I comment out this one, you could see here we're moving from this semicolon character to the integer ASCII encoding, and that's 59. If we add a dot there as before, 46. Okay, and then A, B, C, whatever symbol you have as a character. Okay, so that's implicit typecasting in Java. Let me move this here. Next step we're gonna look at is explicit typecasting, right? Which we did look at here. Okay, so with explicit typecasting, you basically need the data type that you're trying to move to and the expression that you're moving from. Okay, so it's to and then from. Okay, so let's say we had this integer value here as before. Let's look at this here. So here we run this, right? And it says loosely conversion. Let's comment out this one here. It says loosely conversion there. Loosely conversion. What we need to do is, if we want to make this float, which is the highest value in the operands, we'll have to tell it that we want it to become an int. So we would have to say int. That's a type we're trying to move this higher precision type to, and then we have to put the operations in a bracket. So this here is the expression, right, for the operation, and this is the type we're trying to move to, which is gonna match this variable that we have. Okay. So now we get the rounded value, right? So we could put the expression in there. So this is explicit typecasting, right? Let's say we have this float value and we want to move it to a double. So you could move down, precision, or up. Okay, so let's do double here. And then you change here to a double. Okay, so now we're saying even though the things inside this expression is a float, I want it to go up precision to a double, and I'm gonna assign it to this variable here. Okay, there you go. Okay, so that's basically implicit and explicit typecasting. Again, this could work on expressions, or it could work on single variables. Okay, so I could take all these out. Let's say I wanted to move the float here, which is a 12.33f to a double. I could take all these out here. I could keep the brackets or not, right? Because it's just a single variable, and I'm moving this float, which is a 12.33 f to a double. It's not an add result anymore, but it converts it to the double, right? It gives more precision to the float. Okay, what about float to int? Yeah, we saw that before, right, with the expression, and we could do it here again. Okay, so we could move up or down precision with explicit typecasting. But with implicit, usually it wants you to choose the one with the greatest precision, and that's automatic inside the compiler. Okay, so that's typecasting in Java. The next step on our software engineering journey is operators. So what is operators? Right, so these are, you basically, because we call these operands, right? So these variables are considered operands, right? Then you have these different operators in your programming language that you pair the operands with so that you could create operations. And operations create algorithms, right? So the way you do different operations is the way your algorithm is created. It's a step-by-step process, right? So you could have multiple functions in your algorithm, multiple states, and so on. Okay, so this is very important. Operators is the next step in our programming journey. After operators, then we'll see how we control these operations with control structures. All right, thank you for listening. See you later.